solve the system, and yeah, you could graph it, by the way. It didn't say you had to use any specific method, but I'm going to use substitution because right off the bat it says right here x is -2, meaning that in the ordered pair that we're looking for anyways, where you have an x and y value, we just found the x value. It's -2. Okay, there's no other x value in this equation that would make it true. If you replace this x with anything but -2, you'll get a false statement with the equal sign. So with that, now I can go to the first equation and say that x right there, I'm going to replace that with -2. Now the equation shows y equals 2 times -2 plus 3. And this is all stuff that I can put into the calculator. 2 times -2 plus 3. And when you do, you should get -1. Now that really concludes it, because that's the y value, which is -1. And if you were to replace x with -2, we got y is -1. That gave us a true statement for this equation. There is no y value to check on this one. There's only an x value to check for this one. So the y value being -1 doesn't really affect this equation, but it definitely has an effect on this one because we pretty much started with x equals -2. Here's our objective for the day. I can solve systems of equations with elimination. This is our third method for solving a system of equations. We've done graphing and substitution. This one's a little different, but it's meant for a different type of equation, which we will see. So take 30 seconds, copy this down, and we'll get started. So, like we've been seeing in the past, especially with principles of equality, when we look to eliminate, we're going to be eliminating one of the two variables, but we're going to do it with what kind of seems like a principle of equality, okay? But what we do is we kind of line up the two equations, and then we add the two equations together, and that will usually zero out one of the two variables, all right? So usually one of the two variables is easier to eliminate or to make a zero. Sometimes there's not really a clear choice on which one would be easier, which we'll see a problem like that today. But when we get the two equations aligned, what we end up doing is we eliminate, but we do it with addition. So some people refer to this method as the addition method for systems of equations, okay? But again, the whole purpose here, at least in the beginning, is to make zeros. Because if we can make one of the two variables a zero, then it goes away. We could ignore that garbage, right? But the good news is, since we're only dealing with two variables, if we eliminate one of them or make it a zero, then we have a one variable equation, which we just use principles of equality to solve. All right, if we're going to make one of these values a zero, then it's usually good to see the coefficients of one of the variables, again, either x or y. We need one of those coefficients to be opposites. Now, if they come as opposites, it becomes pretty easy to solve, but if they are not opposites, then we got some work to do. All right, now, if you're not sure what I mean by opposites, that means that the number will match, but the signs will be opposites. So we're looking at positives and negatives. And it doesn't matter what the number is, it just needs to match in terms of the number. So you could have like positive 10 and negative 10 x's. All right, and then what we do is we add those together. Like I said, that's why it's considered addition. We would add the y's together and then also the constants, making sure that we bring the equal sign down where it already is. Okay, but by doing this, by seeing this, what happens is the x's become zero, then they eliminate. So we would have down here we would have only a y type of equation. So we can look at a problem like this one. The variable needs to be eliminated to solve the systems of equations below. We don't really need to solve this one. We just want to determine which of these would be easier to eliminate. So since we are looking for opposite coefficients, I see the x's have opposite coefficients. I've got, this would be a positive 4 right there, x's, and then I also have a negative 4 x's. So the x's, which variable would be easier to eliminate or make a zero? Well, the x's have opposite coefficients. So that would mean that the x's would be easier to eliminate here. And again, I'll demonstrate this just quickly. If I were to add these two together, we would have zeroed out all of our x's. But then it would produce a new equation down here with just y's, and then it equals a number. So one principle of equality to solve that becomes a one-step equation. But this one, just on the surface in the beginning here, it looks like it would be much easier to eliminate the x's. So this one, we're looking for the same thing. We want to see if the coefficients are opposites. Now, the only signs that are opposites are for the x's, but the numbers do not match, okay? The y coefficients, the numbers do match, but also the signs, they match as well. For this one, I would say since the coefficients of y's are the same already, it would be very easy, which we'll show you how to do in a moment. It becomes very easy to be able to change the sign, one of the two signs, into a positive. So right here, the y's have the same coefficients. So it would be easy to make the coefficients opposites. Okay, so since the y's, again, just strictly because they match right here, it'd be easy to make those opposites. So on this one, I'm going to say the y's would be easier to eliminate here. Now, is there technically a right or wrong answer? I would say no, but the assignment will want something a little bit more specific like we've done here. So if you are still wondering what is elimination, well, at the top here it says make sure we write both equations in the same form. We shouldn't see anything not written in the same format today. Maybe next time we'll see a little bit different, but for now the format should be the same, and like terms should be in columns, and then the equal signs must be aligned. Now you'll keep in mind with this, if you see an equation that's already in slope-intercept form, meaning if you had something that was like y equals or x equals, usually substitution is a lot easier to use than to just, because you get to skip this first step, right? You get to substitute these values. But today what's going to happen is the equations should be written in some kind of standard form, ax plus by equals c. Now both of them should be in this format, which means that that would be my first equation, but then you'll have another equation, so all these ones, you'll have another equation with a different a value, a different b value, and then a different c value. And we need these x's, the y's, even the equal signs to line up. They need to be stacked, because when we go to eliminate these, eventually, we're going to be adding these, and you have to add like terms. So if this one, for example, was a by plus ax, then you could just switch them, right? Which we've done before. You can take the terms and move them around. So once they're in the same format, which they should be for today, then we've got to determine, sometimes it's easier to eliminate one of these. Sometimes they already come so that the coefficients are opposites for one of the two variables. If that happens, great. We can just add the two together. But if they are not, if they don't match, if they're not opposites, then we have to force them to be opposites. Okay? So that's where we take an equation, and one of the two equations, and we multiply it by something in order to get a coefficient to be an opposite. Now, when we do this, we're going to show it something similar to this one right here, like this. Now, it's going to show us distribution, so we're going to distribute a number, but it's distribution shown as a form of principle of equality, because I would be multiplying these numbers by the same value as I'm multiplying the c, and whatever you do to one side, you have to do to the other side. So it really is a principle of equality, not necessarily distribution, but multiplication will change it so that our coefficients will be opposites. And pretty much we only use multiplication. Now, once the coefficients are opposites for one of the variables, we add the two equations together, which will eliminate or zero out one of the two variables. So we have an equation with just one variable. We solve for that variable. Once we get that solution, that number, then we go to one of the two equations that we started with, and we replace that value into one of the two equations, which will then allow us to solve for the x value. Last thing we should do is check. Today I'm not going to write these out because the calculator will do this work for me, which we'll show you. So, of course, I assume this doesn't make a lot of sense right now, but hopefully by the time we do a couple examples, it will. So here's our first example. Now, there should be some analysis before you do any of these problems, because are these in the same format? Yeah, they are. We got ax plus by equals c on both equations. Okay, are there any coefficients that are direct opposites? Some students would say the -5 and 6 are direct opposites, but that's not true because one is a 5 and one is a 6. So that doesn't work. Okay, we got matching 5 as coefficients of y, but they're the same sign. Okay, but since they match, for me, I'm going to say that it'd be easier to eliminate the y's. So right now, I'm going to choose to eliminate the y's. Okay, so we'll eliminate the y's first. But in order to do that, I need to take one of the equations and force the coefficient to be an opposite, meaning one of them, they're both positive, I need one of them to be a negative. Now, it doesn't matter which equation you do it with. I'm choosing to do it with the top one. Okay, so this equation right here, I'm going to force the coefficient of y to become a negative 5y. Now, there's going to be more to it than that, so I've given myself some space. But how do you make a positive a negative with multiplication? Well, I know that you can do that with negative 1. Now, again, this is a principle of equality, but we're showing it like distribution. So first off, I would do negative 1 times negative 5x's, because I've got to multiply everything. That's the principle of equality, which would give me positive 5x's there. Now the next one, this will produce the negative 5y. Negative 1 times positive 5y's will give us negative 5y's. And then this would equal negative 1 times the negative 10. You got to multiply everything. That'd be positive 10 right there. So that will give me a negative 5y, meaning that I don't really have to do anything with the second equation. It's just 6x plus 5y equals 1. So the purpose of that was to get the y's to have opposite coefficients, and they do. So since they're opposite coefficients, I'm going to go in and I'm going to add each of the columns. So I'm going to start with my x's. I've got 5x's plus 6x's. How many x's is that? That'd be 11 x's. Okay, what happens to the y's? Well, guess what? They zero out, and that was planned. We were planning that. That was what that work was when we were using the principle of equality with distribution. Okay, the equal sign needs to stay in the same place, but 10 plus 1 right there is going to be 11. Well, this is good news because it's 11x equals 11. It's just a one-step equation. In order to solve this, all I got to do is take both sides and divide by 11 to make this a 1x. So I'll take 11, I'll divide it by 11. Some of you like to do this with the fraction line, and that's fine too. But 11 divided by 11 is 1, so 11 divided by 11 is 1, meaning that I have just found the x value. So, in my ordered pair, because this is still an ordered pair for us, I just found an x value that should work, 1. So, it doesn't matter which equation I choose, I just got to replace the x with 1. I'll just choose the top one. I tend to just choose the top one. But you could have chosen the 6x plus 5y equals 1. It's up to you. So negative 5x plus 5y equals negative 10. Now down here, we found that x is 1. So I'm going to take the x in this equation right here, and I'm going to replace it with 1. So I'm going to go in, take that x, let's get rid of it, or replace it rather, with 1. Okay, so we're solving this equation now for y because it's the only variable that remains. And to solve this, I'll have to do some distribution there. I got negative 5 times 1, which is negative 5. It'll be negative 5 plus 5y equals negative 10. Now, that's all the distribution I have. There's no combining like terms. So I'm going to keep my y's on the left because they're already there, and my numbers on the right, which means the negative 5 here in orange, yeah, it's on the wrong side. So, because it doesn't have a y, I have to zero that out. Add 5 there, but it's a principle of equality. If I do it to one side, I got to do it to the other side. Zero out. That was part of the plan, by the way. Now I've got 5y equals negative 10 plus 5 is going to be negative 5. That's great because one last principle of equality should solve for our y. We'll divide both sides by 5. So I'm showing the division differently. That'll give us phantom 1y. So I'm not showing the 1 anymore, but negative 5 divided by 5 is going to be negative 1. That should be my y value. So I'm going to put it into my ordered pair. But the last thing I'm going to do is check. But when I check this stuff, I'm going to put it into the calculator instead. So I would type in negative 5 times 1 plus 5 times negative 1, and I see if it's negative 10. It would be. So I hope you put that in the calculator. But for me, that first one, and I'm going to put a check mark here just to make sure that I can remember that I checked it. Yeah, it's good. But we've got to do both equations. So the second equation, 6 times 1 plus 5 times negative 1, is that 1? Yeah, put that in the calculator, you will get 1. So that one checks off. Both have to check off, and the check mark indicates that it's true. So since both of them are true with these two values, I know I found the intersection between the two lines if we were to put these on a graph. Okay, so we checked it. That was the last step for us. A little bit of work here on this equation. to solve it, but it's work that we've done. So for those of you that have been paying attention, yeah, this stuff should be fairly easy. You just got to know to replace stuff, and maybe in the beginning how to get and force these coefficients to be opposites. I start out, I got negative 3x and 3x, and then I've got 10y and 7y. I don't really care about the constants. We're not looking ever to eliminate these, although if they did, that'd be fine. You can have a 0. But the x coefficients, they're already opposites. So for me, I would start by eliminate the x's, okay? Now, could you eliminate the y's? Yes, you could. But that's going to be a lot more work than I want to do. And since I'm a math nerd, I'd like to do less work. So, to start out here, I'm going to take the two equations and I'm just going to add them together. Now, in doing so I'm going to add the x's, the y's, and the numbers. They're already set up in columns. They're in the same form. So I don't have to move anything around either. But by doing this, right at the beginning here, we've got negative 3x plus 3x. That will be 0 x's. Now, I don't really want to write 0 x's down here, so I'm not going to. I would just like to ignore it. Okay, so the x's go away. They eliminate, which was, I mean, we didn't really plan it that way. It just came that way. But then, how many y's do we got? Well, 10 plus 7 would be 17 y's. And then this would equal 17 plus 17, which is 34. So, just like we've seen, there should only be one last principle of equality now to solve for y. I should get y equals after this. All we got to do is take the coefficient 17 and divide it by itself. But if you do it to one side, you must do it to the other side. 34 divided by 17 is 2. So we have that ordered pair. So down here in the bottom left, I'll put my ordered pair. I know it's always an x and a y, and we just found a y value of 2. Now if this works, then it should make the y true for both. And we found then the y value, we got to find the x value. Once again, it does not matter which of the two equations you use. Some students say, well, I like this one because it's all positives, which you can do. I'm just going to choose the top one because it's on the top. That's it. So I'm gonna rewrite it. I got negative 3x plus 10y equals 17. But we just found down here, we just found the y value is 2 here. So I'm going to go in there, I'm going to take that y, and I'm going to replace it with the value that we're pretty sure it is. It should be 2. And this becomes an equation for us to solve. There is distribution, which is multiplication between the 10 and 2. 10 times 2 would be positive 20. Okay, so we got negative 3x plus 20, and then this will equal 17. I want to isolate my x's. They're already on the left, so I'll keep them there. Numbers on the right. So the 20, which does not have an x, is on the wrong side. I've got to zero out this garbage. So to zero out that positive 20, I'm just going to subtract 20. But I got to do it to both sides. Now I'll take the negative 3x and drop it. The 20 minus 20 zeroes out. That was part of the plan. And 17 minus 20 would be negative 3. So one last principle of equality will solve for our x. So here we go. We'll divide both sides by the coefficient of negative 3. That's the black negative 3, not the orange one. And that'll become a phantom 1x. Negative 3 divided by negative 3. I do need that one, though. So the x, it appears, is 1. Well, if it appears that it's 1, is it actually 1? And is the y actually 2? Well, I got to go back to my original two equations. Again, I'm not going to show the work here, not just for the sake of space, but also time. Because this is all stuff you can plug into the calculator. So I'd have negative 3 times 1 plus 10 times 2. That'd be negative 3 plus 20. Yeah, in your calculator even, that should show that that one right there is going to check off. So check mark. That's true. How about the second one? Well, that'd be 3 times 1 plus 7 times 2. That'd be 3 plus 14, which is 17. So the second one also true, meaning that we have in fact found the solution. So, I mean, you can box it in if you like, however you want to do it. But that is in fact the solution. Or in other words, if you were to graph these two equations, this is where the two lines would intersect. Now, just like we had started this lesson, the first thing you want to do is just see, is there one that's going to be easier to eliminate than the others? Well, if that's the case, if there is one that's easier than the others, then the coefficients should be probably matching first. And right off the bat here, you've got negative 1x and negative 1y equals 20 for our second equation right there. So I don't see any matching values, but what I do notice is that the coefficients are already opposite signs. We got a positive x and then a negative x. Positive y's and then a negative y. So the signs are already opposites. What this means is that it doesn't really matter which of the two that I choose to eliminate. You can choose to eliminate the x's, you can choose to eliminate the y's, it's not going to matter. But also neither of them is going to necessarily be easier than the other. So I'm going to choose to eliminate the y's. But why am I choosing to eliminate the y's? It's because the y's have the lowest coefficient, and that's the only reason. Now, does that mean you have to do it? No, because for some of you, you'd be like, I think multiplying by 4 would be easier for me. Okay, that's fine, and you can do that, all right? But for now, all I'm going to do is I'm going to focus on eliminating the y's for now. So if that's the case, I need the coefficients to be opposites. So they're already opposite signs, but are they true opposites? No, we got a 1 and a 2. I can make this one match a 2 pretty quickly. And here's how I'm going to do that. So I'm going to take this full equation. Again, it's really a principle of equality, even though it's going to look like a distribution. And I'm going to multiply it by 2. Right? So here's what this does. By distributing, which is really principle of equality, this is going to give me a new equation. So first we would have 2 times negative 1x, which would be negative 2x's. Then I'd have 2 times negative 1y, which would be negative 2y's. That was actually part of the point, right? Because this negative 2y is now an opposite of the positive 2y. Okay, but continuing, is again, it's showing as distribution, but it's a principle of equality. I'd have to multiply by the 20. 2 times 20 is going to be 40. Now that top equation, we didn't really do anything with it, so it's still a 4x plus 2y equals negative 60. So just like we've been talking about, we have the y's lined up, but they're also opposite coefficients. So now that I have these lined up and we have opposite coefficients, I'm ready to add the two equations together. So we'll start from left to right. I'll start with the 4x. I'm going to add this negative 2x's. How many x's is that? Well, that'd be really 4 minus 2, which is 2x's. The y's, they should eliminate, right? If we've done this correct, well, 2y's minus 2y's, they do eliminate. You could show 0y right there, but I don't know why you would. So I'm going to keep that off. Okay, that was the whole point. We wanted to eliminate, we wanted to go away. And this would equal, so we want to align our equal signs as well, but then we would have also negative 60 plus 40, which is going to be negative 20. So just as planned, we got rid of the y's, and now we have an equation that just has an x with it. So we have a one variable equation. We can use principles of equality to solve it. Okay, so what I would like here is a 1x. How do you make a 2 a 1 coefficient? You just divide it by itself. But if you do it to one side, you will need to do it to the other side too. So negative 20 divided by 2 is going to be negative 10. Now that should be the x value in my ordered pair. We got an x and y value. We just found the x value is negative 10. So we have an x value. What we need now is a y value, and we're going to go back to the two original equations up here, and we're going to replace the x, one of the x's, with negative 10 and then solve for the y value. It does not matter which of the two equations you choose to use or to solve for the y. Okay, I'm going to choose the top equation just because I tend to choose the top equation. So that's 4x plus 2y equals negative 60. But I just found that the x value is negative 10, or I'm pretty sure it is. So I'm going to go in here, I'm going to take the x and replace it with negative 10. Okay, this is an equation now. This equation that we have is now an equation with just a y value. That's good, because I can solve. I'll distribute, which is multiplication. 4 times negative 10 is going to be negative 40. And we still got the rest of it, so plus 2y equals negative 60. And at this point, I've got all my y's on the left. So I'm going to keep them there. I'll say y is on the left, number is on the right. So my negative 40 is on the y side, but it doesn't have a y, so it has to be zeroed out. It can't be there. So I'm going to have to add 40 to both sides. So negative 40 plus 40 would zero out, as was part of the plan. We can drop our two y's, which equals negative 60 plus 40 is going to be negative 20. And then the last step here, we just want a y value, so we're going to divide both sides by 2. Now I'm not going to show the phantom 1 anymore. Well, it is a phantom 1. But I'm not going to show the 1 anymore. So there's a phantom 1y down here at the bottom. But we got negative 20 divided by 2, which also is negative 10. So it's fairly rare for this to happen, but the x and y values match. It's okay that they do. But the last thing we're going to do, we have an x value, we have a y value. Last thing we want to do is just check to make sure that it would make these two equations true. Now again, I'm not going to show the work, but you're replacing the x with negative 10 and the y with negative 10. This would be 4 times negative 10, which is negative 40. 2 times negative 10, which is negative 20. Negative 40 plus negative 20 is negative 60. So that first equation does check off. Now, by the check mark indicates that it's true if you replace the x and y with negative 10 and negative 10, respectively. The next equation would be negative 10, that's positive 10, minus negative 10, which would make that plus 10. That'd be 10 plus 10 is 20. So again, I'm not really putting in the calculator, I'm just kind of going through it in my head. But I can put a check mark next to that one because it was also true. Since it is true, what this means is that if you were to graph the two lines, these two lines over here, you would find that they intersected this ordered pair negative 10, negative 10. So this means we have in fact found the solution, which is what we wanted the whole time. But we've done this now with the elimination method. Now just so you understand, you could probably reorganize this equation so that it's a y equals or x equals and then use substitution if you wanted to. But for me, I think it's easier just to do some multiplication here with the principle of equality, get your new equation, eliminate, and then solve a couple equations. So on these two equations, we got x minus 10y equals 18, negative 6x minus 10y equals 32. So I see the y's have matching 10s, but they're negative 10s. What we need these signs to be are our opposites. So the 10s are nice to match, but we need those to be opposite signs. So that way, if we were to add these two together, we could eliminate them. Now, along those lines, there is a phantom 1x right there. But the x coefficients, we got a 1 and a 6. We're positive 1, negative 6. So even though they're opposite signs, I'm going to leave those two alone. Because changing the 10s into positives or negatives should be fairly easy. Now, it doesn't matter which equation you change, the negative to a positive, but we only need to do it to 1, so that they are opposites. I'm just going to choose the top one. Why am I choosing the top one? No really specific reason other than it's on top. Okay, now, what we need is a new equation, right? We're looking at the y's. Instead of it being a negative 10y, we need it to be a positive 10y. How do you take this negative 10y's and make it a positive 10y's? What we're going to do is we would need to multiply it by negative 1. So this will just pretty much change the signs for us, and it will change the negative 10y into a positive 10y, which is what we want. So I will use some distribution. Again, it's really a principle of equality because we're doing it to all the terms, but negative 1 times 1x's would be negative 1x's. Negative 1 times negative 10y's is the positive 10y's, just like we wanted. But then also we got negative 1 times 18, which would be negative 18. So it equals negative 18. The second equation, it's okay. It can just be as it is. Negative 6x minus 10y equals 32. So the coefficients of y's do, or they are opposites. So this should eliminate. Now, in today's lesson right now, we've only been able to, we've only needed to change one of the equations. But it's likely in the next lesson that we'll have to change 2 of them. And that's okay if we need to. We'll go over it. But my 10y's, my y's are opposite 10s. So if I were to add these together, they should eliminate, right? So let's start with the x's. negative 1x's minus 6x's would be negative 7x's. 10y's minus 10y's, it does actually zero out as planned. And then this would equal negative 18, also the plus 32. Negative 18 plus 32, which is 14. Okay, so we now have a one-step equation to solve, because what we would like this to be is just a regular phantom 1x. So we'll take that negative 7, we'll divide it by itself, but if I do it to one side, I got to do it to the other side. So that'll be a phantom 1x. 14 divided by negative 7 is negative 2. So we just found the x value in our ordered pair, x and y. So I take my x, I say I know it's negative 2, at least I'm pretty sure. So we found the x value. What we're missing then is the y value, which we did eliminate, but it doesn't matter which of the two original equations I use. I can choose the top one, I can choose the bottom one, but to stay consistent with this lesson, I'm just going to choose the top one, okay? So that was x minus 10y equals 18. And we're pretty sure over here we found an x value that's a negative 2. So I'm going to come over here and take this x from our top equation, and I'm going to replace it with negative 2. So take it away, take it and replace that x with the value that we found, which should be negative 2. Well, this becomes an equation for us to solve for y, because now it's just an equation with just a y. And to solve it, we'll use the principles of equality. All my y's are on the left, so I'll keep them there. Numbers on the right. So the negative 2 in green, it doesn't have a y, but it's on the y side. It can't be there. So I'm going to have to add 2 to both sides. So negative 2 plus 2, that zeroes out, and that was part of the plan. I'll drop this, it's really negative 10y's equals 18 plus 2, which is 20. The last thing I need is a phantom coefficient of y it's going to be shown as a phantom 1. So it should end up being a y equals. Now, how do you make a negative 10 coefficient a positive 1 phantom 1 coefficient? It's divided by itself. So divide both sides by negative 10. On the right, we got 20 divided by negative 10, which is negative 2. So my y value should be negative 2. And this should solve it. But again, I'm going to go back to the top and just check. I'm going to put the x in as negative 2, the y is negative 2. Let's see what we get if we were to do that. So up here, first off, we got x is negative 2 minus 10 times negative 2. That'd be like a negative 2 plus 20, which is 18. So again, I'm doing this in my head, so you should be doing it on a calculator though. But that first one's true. The second one, negative 6 times negative 2 would be 12. 10 times negative 2 is negative 20. So it'd be 12 minus 12, it'd be 12 plus because it's minus negative 20, which would be 32. Yeah, so that checks off as well. Both equations are true when I replace the x and y's with negative 2, negative 2. Which means, once again, if you were to graph these two lines, these two equations as lines on a graph, you'd see they intersect at negative 2, negative 2. So we did find the solution. Now that's all we got. So as long as you can solve a system by elimination, that's good. The next lesson is also about elimination, but it's going to have more of that stuff where we're going to have to force the coefficients to be opposites, which we can see it's just a matter of multiplying one of the equations, or sometimes both by a certain value.